Okay, the other thing we're going to talk about when we're talking about zeros of polynomials is the rational zero test. It's actually kind of an interesting little test. We won't prove it, but it is a theorem, so this is the rational zero test. Now this doesn't find all roots, but it finds any possible rational roots of a polynomial. So if f at x is a polynomial, I'll just say if f of x equals, it's a polynomial, but we'll say an x to the n plus an minus 1 x to the n minus 1 plus dot 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 a1x plus a0. So if this has integer coefficients, so we have a fairly major restriction here, so it's got to be integer coefficients. But we often see that. Then every rational zero go back. I don't know how it switched there. Every rational zero has the form P over Q, where P and Q have no common factors but 1, and P is a factor of a0 and Q is a factor of an. Okay, so let's look at a couple examples of this here and how we can find rational zeros using the rational zero test. And it's very helpful when you have the an being 1. If an isn't 1, you can still use it, it just tends to be a little bit more tedious. So let's look at an example here. So let's look at f at x is equal to x cubed minus 5x squared plus 2x plus 8. Now these are all integer coefficients, and I'm trying to determine how many, or trying to determine what the rational zeros of each function are. Well, here an is equal to 1, and then a0 is equal to 8. Now, the nice thing when an is 1, there's only, of course, one possibility here. Well, technically there's two. Factors of an are plus or minus 1. Alright, well then the factors of a0 we get positive and negative as well. Well, make sure to include all of them, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So let's go ahead and just, how do we know which ones? Well, you just have to test. So let's test f at 1. Now that's saying these are the only possible rational solutions. If none of these are rational solutions, then we won't have any. Now it turns out there's other theorems that pretty much guarantee us at this point that because we have these nice integer coefficients, we're going to have to, and it's an x cubed, it's going to have one rational root here. So let's just go ahead and see if we can find it. So f at 1, well, this would just be 1 cubed minus 5 times 1 squared plus 2 times 1 plus 8, which would be 1 minus 5 minus 4 plus 2 minus 2 plus 8 is 6. Right? Yeah, so this would be 6. So clearly 1 is not a 0 because I didn't get 0. Okay, well let's try f at negative 1. So this would be negative 1 to the third minus 5 times 1 squared I'm sorry, 5 times negative 1 squared plus 2 times negative 1 plus 8, which this would be negative 1 minus 5 minus 2 plus 8, and this is 0. Well, what does that mean then? That means that negative 1 is a 0, so x plus 1 is a factor of x cubed minus 5x squared plus 2x plus 8. Alright, so it's a factor of that. So how do we find the other ones? Well, I could do division here, which is what I'm going to do, because I don't know if the other ones are going to be rational, but I will get a quadratic if I do the division here. So let's go ahead and do the division. So we have x cubed minus 5x squared plus 2x plus 8, and then have this divided by x plus 1. So we go through here. I'll just write this here as x. Maybe I'll write it. There we go. X squared. And then x squared times x, of course, is x cubed. And then I'd have plus x squared. And then subtract. And so doing the subtraction, you would wind up with negative 6x squared. Bring down the next term, plus 2x. And so then you'd be multiplying by minus 6x. And so then you'd have negative 6x times x, which is negative 6x squared. Negative 6x times 1 minus 6x. Again, subtract, and you'd wind up with 8x plus 8. And then you would have this would be, the last one would be plus 8 then. And so you'd have 8x plus 8, and then subtract, get a remainder of 0, which we already knew we were going to do, get. And so then what do we know? Well, we know now that x cubed minus 5x squared plus 2x plus 8 is equal to x plus 1 times x squared minus 6x plus 8. Well, now what can I do? I can use the quadratic formula or see if it factors. Now, it does factor, and this factors to x plus 1 times x minus 4 times x minus 2. Now notice, minus, positive 4 and positive 2, which are the other two zeros, were going to be options here if I had gone through and evaluated all of them. But just because these are the all possible rational, remember, you don't have to have rational solutions. We've had solutions when you use quadratic formula where you get square roots. Square roots aren't rational. Rationals are fractions, right? So let's look at another example here of this. This will kind of wrap up this section on zeros. So let's look at one that has a little bit more going in here. So we have, let's find the zeros. of f at x equals 6x cubed minus 4x squared plus 3x minus 2. Okay, so this one, let's go ahead and write down my factors of my ANs and everything. So AN is equal to 6 and A0 is equal to negative 2. So factors of, well, let's do A0 would be plus or minus 1 plus or minus 2. And the factors of AN, well, these would be plus or minus 1 plus or minus 2. What is going on here? There we go, plus or minus 2 and plus or minus 3 plus or minus 6. Now, when we do these, remember, we're going to take something, a factor of A0, and then divide it by AN. But when we do that, the greatest divisor between the two factors can be 1. That's the only common thing they can have. And what do I mean by that? Well, if we do the first one, you'd have plus or minus 1 as a possibility. And then let's just keep doing the 1s here. So then you'd have plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Okay, well now let's look at here the plus or minus 2. Well, you would have 2 over 1. So that's plus or minus 2. You'd have 2 over 2, which actually we don't do. I mean, if you did it, you would just get plus or minus 1 again, which we already have written there. Plus or minus 2/3. And then plus or minus 6, which again we wouldn't do because we already, because those both have a factor of 2 that share in common. But if you did do it, 2 over 6 reduces to 1/3, which we already have. So you can see real quickly when we don't have 1 as the AN, we get a lot of different possibilities here as far as what the factors are. Now, to speed things along, you could go through and check all of these, but I'm going to just have us check 1, and I'm going to have us look at f at 2/3, and this is where kind of the rational zero test can kind of sometimes fall apart for us because it doesn't necessarily get us the answer quite quickly, because if I went in order here, 2/3 is probably one of the last ones I would check. But if we do this as far as the arithmetic, this would be 6 times 2/3 cubed minus 4 times 2/3 squared plus 3 times 2/3 minus 2. And so this would be 6 times 8 over 27 minus 8 over, well, 4 times 8 over 9. Emphasize this is multiplication there. It's not 4 and 8 nines. It's 4 times 8 over 9 plus 2 minus 2. And actually, I'm sorry, this isn't 8 here. Hello? It's like something's not adding up right here. This is 4. 2 squared is 4. Alright, so this is what we'd have here. And then this would be end up being 2 times 8 over 9 minus 16 over 9 plus 2 minus 2 is 0, and then this is equal 2 times 8 over 9 is 16 over 9, and so this would be equal to 0 as well. Alright, so you could get that. And then we could go through the long division, which I am going to skip that as well. We've done several long divisions at this point. And if you do the long division out, you'd get f of x is equal to x minus 2/3 times 6x squared plus 3. Now, we've technically found all the rational zeros, because if I want to find when this thing is 0, 0 is equal to x minus 2/3 times 6x squared plus 3. Well, this would be x minus 2/3 equals 0, or 6x squared plus 3 equals 0, which this gets me x equals 2/3. Now you could apply the quadratic formula to the next one if you wanted to, or I would just write this as 6x squared equals negative 3, x squared is equal to negative 1/2, and so then x is going to be plus or minus I times the square root of 1/2. And so that's what it would be for the others. And now again, notice that this is a conjugate pair here, so which if we have complex, it would occur in conjugate pairs. Okay, so this wraps up our discussion on zeros of polynomials. Now, there will be some story problems on some of the exercises, and we haven't done very many story problems in these later sections, but really I feel like I can do story problems left and right. They don't necessarily help you find the way to do them. The best way to get good at story problems is just to keep doing them, and if you need help, getting some additional help as you're doing them. Alright, so we will be moving into a new topic in the next set of videos. So we're wrapping up on our discussion of polynomials, and then we're going to moving into rational functions, which are related to polynomials.